I'd like to teach today is unit number 10.6. Unit number 10.5. Unit number 10.5 starts on page 732. And this is all about tangents. So I want to start at the top of the screen here and talk to you about some types of tangents. First of all, in this position right here, way at the upper left corner, we have some lines that are tangent to one another, or circles that are tangent to one another in this red circle here. We have two circles that are tangent at point A, that little red dot between the two circles. So if two circles touch, these circles are said to be externally tangent. The next picture I have here in blue, letter B, are lines that are internally tangent. So one circle is inside the other. Those circles are internally tangent. In picture C, I have circles that are not tangent at all. They don't touch each other. However, lines can be drawn that are tangent to both of these circles. And I can think of 4 lines, 2 of them on the outside like this one here. There's another one on top over here, okay? There's also some that go through like this, okay? And some that go through like this. Now, what does the word tangent mean? Tangent means touching at one point. In picture A, the one that's circled in red, the 2 circles touch at one point. They are externally tangent. In picture B, the 2 circles are tangent at one point. In picture C, the 2 circles are not tangent, but tangents or lines can be drawn that touch both circles in one point. And then in letter D, those 2 circles there have no tangencies at all. The one circle's inside the other one, and you cannot draw a line that touches both circles at one point. That's just not possible. For example, if I was to draw this line here, it would touch the little circle at one point, but it would touch the big circle at 2 points. And that would be here and over here. And therefore, that's not a tangent, because a tangent is something that touches something else at one point. Okay, moving on here. In my next picture, I have a line, L, and it is drawn to a circle labeled A. And I have this line L is tangent to the circle. Line L is tangent to the circle A. And what does that mean? Well, it means it touches it at a point of tangency. And that's the point of tangency, let's say. And we could label that B. Okay, more information. It's known that if a line is tangent to a circle, then the radius to that point, let's label this point B, the radius to that point is actually perpendicular to the tangent, okay? Take any circle, draw a tangent to that circle. I could draw a tangent here, okay? It might touch at this point. Draw the radius to that point. That forms a 90-degree angle, okay? All right. So that's the information I've given right here. AC is tangent to BC, which is the radius. A line tangent to a circle is perpendicular to the radius at that point. In this case, the figure is BCA. That's the triangle that's formed. All right. And since this is a right triangle, you can apply it to the Pythagorean theorem. BC squared plus CA squared equals BA squared. Notice that the point of tangency, that 90-degree right angle there, tells me that the right angle's out there, okay? So just try to remember always where the right angle is, because you're going to be doing a lot of problems where you have to use the Pythagorean theorem to determine if it's a point, if CA is tangent, and or in some cases, you're given that CA is tangent and find, let's say, BC or BA. Okay, so we're going to be using the Pythagorean theorem a number of times. A squared plus B squared is C squared, and C squared is always the line across from the right angle. And that is the information dealing with Theorem 1010. I'd now like to go on to Theorem 1011. From a point outside a circle, there are two tangent lines that can be drawn. So what I did here is I drew a point A right here, okay? I labeled A, and I drew a tangent to the circle at the top in red and at the bottom of the circle in blue, all right? And there's some interesting things about this that we'll be using. In fact, one of them is that the distance CA is equal to the distance AB or BA, all right? So if I was to put that in words, from a point outside of a circle, there are two lines of tangency that can be drawn, and these two segments are equal in length. CA equals AB. Now again, we're going to be doing a number of problems with that fact, but also a number of problems with the fact that CA squared is plus C to the center. Let's call this D, point D to the center here. So CA squared plus CD squared is DA squared, the hypotenuse. DA squared, okay? So that goes back to this idea right here. Okay, let's look in your textbook now at some applications of the things that I've just told you. And we're going to turn to page number 735. I'd like to look at number 2 with you. Notice we have here the instructions, determine whether FG is a tangent. Number 2. So if FG is tangent to the circle at EG, that means that EF squared would equal to GF squared plus EG squared. The question is 6 squared plus 10 squared equal to 12 squared, yes or no? If it is equal, then it is a right angle. In other words, angle G is a right angle, and FG is a tangent. Same thing for number 3. If FG is a tangent, then FG squared plus GE squared equals FE squared, because angle G would be the 90-degree angle, yes or no? Moving on, let's take a look at problems 4 to 6. Assume that the segments are tangent. Okay, number 4, then 16 squared plus 12 squared equals x squared. Number 5, AC squared equals AB squared plus BC squared. Number 6 goes back to the idea that tangents from a point are equal in length. So 3x would equal 5x minus 8. You can solve that. Let's take a look at problems 9 through 12. So number 9 goes back to my first picture, way at the top here. This picture right here, okay? These two circles are externally tangent, aren't they? The question is, copy each figure and draw the common tangents. Okay, so if you need to draw the common tangents, they're asking you how many lines can be drawn in different positions that are tangent to both circles. So in this case, you could have this line here, that's tangent to both circles. This line here, that's tangent to both circles, but also a line right through the middle that's tangent to both circles, all right? Problem number 10, that's this situation right here. We discovered that if one circle is within the other circle, you can't have a line of tangency at all. 11 and 12, you should be able to do those. So how many lines can be drawn between the two circles or outside the two circles that touch both circles at one point? Numbers 13 through 16, the question is it tangent? So again there, does 25 squared equal 7 squared plus 24 squared for number 13? That's how you're going to do 13 through 16. Problems 17 through 22 assume that the segments are tangent. All right, here we're back to For example, number 17, QN squared is across a 90-degree angle, P. So QN squared equals 24 squared plus 10 squared. Problem number 20, the right angle is angle S, so RT squared plus ST squared equals RS squared. 12 squared plus, oh, this one's a little challenging. It's not just 12 squared, it's actually 12 plus X squared equals 20 squared plus RS squared. So remember that when you square 12 plus X, what do you get? You get a trinomial. 12 times 12 is 144. Using the FOIL method, by the way. 12 times X doubled is 24X plus X squared. So that's quantity 12 plus X squared. Maybe I'm going to do that for you really quick here to show you how that works. Let me just erase something here and just talk about this for a second. So when I square 12 plus X, I use the FOIL method. So that means I'm taking 12 plus X times 12 plus X. So that's 12, FOIL, right? FOIL. So 12 times 12, that's first, plus outside 12 times X, plus inside X times 12, which is 12 times X, and X times X, which is X squared. Okay, so on that problem number 20, what we just said, those three terms, equals 20 squared plus RS squared, and you can solve for RS. 21, the two tangents are of the same length as in 22. All right, so we're going to be doing problems 1 through 22 on page 735 and through 737. And that will be due for next week, Tuesday.